Alright, so in this video I'm going to talk about confidence intervals and error bars. So in the previous video I showed you how to calculate standard error of the mean, and we got 0.90 for both. So now what are we going to do with that? Well, first of all, what does it mean? Well, that tells you how far our data strays away from our mean if it were to be placed on a distribution curve. All right, so the first thing we're going to need to do is we're going to need to come in here and complete our graph. So the first thing we need to do on our graph is to label the axes. So the y-axis, so since my means are 10.27 and 5.73, I'm going to come in and label my y-axis by halves. Okay, so next we need to label our y-axis, and we think for a second, what should our label for our y-axis be? So we're graphing the means. This is going to represent the mean average number of pill bugs per wet and dry. So we're going to put mean number of pill bugs. I'm going to do this here, just like that. Mean number of pill bugs. Kind of hard. There's not a lot of room there to do that. So we're going to label this. Since it's our independent variable, what we were testing was wet versus dry. So here we're going to have wet. I'm going to come over a few spaces here. Not too far. We want to keep our columns pretty close together so that we can really compare them with each other. And then dry. Alright, so now we're going to graph our means. So for this, we're going to use shapes. I'm going to go with a rectangle. And I will go with green or let's go with blue for wet. Alright, so I'm going to go here. So for wet, it was 10.27, so it's going to be way up here. 10.27. And then dry, we'll go with red, was 5.5, I believe. Let's go back up. 5.73. So just under 6. We're going to go up. Just under 6, just like that. All right, so there are our means. Now the next thing it asks you to do is to graph with error bars. Alright, so if we go back to our instructions up here, number 12 said create a bar graph which displays the average number of pill bugs on each side of the choice chamber. Calculate the standard deviation and standard error of the mean for each group. We've done that. Now it says use standard error of the mean to draw error bars for your graph. Use plus or minus 2 standard error mean to create 95% confidence intervals. So what that is basically saying is that we want to have 95% confidence in our data, in our means. And obviously 5% left over for error, standard error of the mean. So we want to account for 5% error. So we're giving ourselves a little bit of leeway because things unpredictable will happen. For example, when you were watching the video, one of the pill bugs actually escaped. So we're going to account for 5% error. And then the last thing we'll do is use a chi-square analysis to analyze the 10-minute data and the sum data. But first, let's go over these confidence intervals. So just like anything, you should be able to refer to your notes. And on page 13, start talking about confidence intervals. Okay, so what does that actually mean? So the standard error of the mean and the 95% confidence interval are used to construct error bars for graphs showing the mean values of data sets. In AP Biology, the error bars usually show the range 2 standard errors above and two below the mean value. So that's that plus or minus 2. So plus 2 and then down below 2 on our graph. To create a graph with error bars, the graph the means of each data set using the bar chart. Starting at the mean for the first bar, move directly up 2 times the standard error of the mean. At that point, draw a horizontal line centered over the bar. All right, so let's do that first. All right, so we're going to go back to our lab here. We're going to see, all right, our standard error of the mean was 0.90. So we're going to go up 0.90 from our means twice. So 0.9 in my calculator here, 0.9 plus 0.9, 1.8. So our mean is 10.27. So 10.27 plus 1.80 equals 7 to 12.07. All right, so I need a little more room on my graph here, so I just pretend there's going to be lines there. That obviously is not the right thing to do, but I'm just going to overlook it to serve my purposes here. So plus 2 SEM, we said, was 1.8, so we added that to the mean, 12.07. So we're going to click on our shapes here and insert a line. So I'm going to do a red line. Actually, I'm going to do a black line. I'm going to go up to about 12.07. All right, and then it says draw a horizontal bar right above that, just like that. So now, in our notes, the next thing it tells us to do is to go down to SEM. All right, so we're going to subtract 1.8 from 10.27. All right, so let's get the drawing feature here. So 10.27 minus 1.8 equals 7. 4.8. Sorry for the bad handwriting. I forgot my stylus pen today, or if not forgotten, I maybe lost it. That's okay. All right, back to our lines. So we're going to go down 8.47. Going down here, drawing a line straight across. And there you go. So here are our error bars showing 95% confidence. So obviously this mean and that mean are two different means. They're very far apart. But now we're going to draw the error bars for this one. We're going to see if those error bars overlap with these error bars. And if they do, then that will tell us something. Also, if they do not, that will tell us something also. So I'm going to do that. I'm going to pause the video, and I will do that. So we're going to draw. We're going to do 5.73 minus, and our standard error of the mean for this set of data is also 0.9. That's not always going to be the case, but this time it is. So that's 1.80. And then we're going to do 5.73 plus 1.80. 3, 5, 7. So we're going to go up to 7.53. 3, 9. Let me check my math real quick. good to go. Okay, so we're going to come here and we're going to go up, do the error bars again, 7.53. So from our mean, 7.53 be right about there. Horizontal line, just above this line. That. I'm going to go down 3.93. Just below 4. There you go. All right, so notice that our error bars do not overlap. All right, so to figure out what that means, we're going to have to go back to our notes. So going back to our notes, it says here back on page 13, it says the vertical space between the two horizontal lines represents a 95% confidence interval. This means that you can be 95% sure that the mean for the entire population falls within this interval. So we have 95% confidence in our means. As a researcher, you may want to use your collected data to compare samples or groups and determine if the groups are significantly different. A significant difference means that the results are seen in the data, that the results that are seen in the data are most likely not due to chance or sampling error. In any experiment or observation that involves sampling from a population, there's always a possibility that an observed effect could have occurred due to sampling error alone, which obviously with me doing that, it's going to happen. Error is going to happen. But if a result is significant, the investigator may conclude that the observed effect actually reflects the characteristics of the population rather than just sampling error or chance. Okay. So if it is a significant difference, then that means what we saw is actually what we think is happening. So look down here. The standard error bars on a graph can be used to get a sense for whether or not a difference in two groups or samples is significant. Look for overlap between the bars. So here it shows overlap, this shows less overlap, and this shows no overlap. So that is what our graph or my graph looks like. There is no overlap. When error bars overlap quite a bit, it's likely that the difference between the two groups is not statistically significant, and the differences are probably due to chance or sampling error. So this difference between this mean and that mean is, like it says, probably due to chance or sampling error. That means that there's not a lot going on to account for this difference other than chance or sampling error. You must actually perform a statistical test to draw a valid conclusion. But in AP Biology, you can simply say that if the error bars overlap, that the two groups or samples are not statistically different. On the other hand, if there is no overlap between the bars, the differences between the groups is likely to be statistically different. So here we would say there is no overlap, so the difference between the two groups is likely to be statistically significant. So there's something actually going on here to cause this large difference between these two means. So maybe those pill bugs actually are preferring one side to the other. Okay? And so this difference is not just due to my error, it's due to the pill bugs maybe actually choosing one side. All right, and you have practice problems in your notes that you can go through if what I just did not help. If you refer back to the lab, number 1 says, based on your bar graph and error bars, is there a significant difference between the number of pill bugs found on the wet and dry side of the torch chamber? Justify your answer. So then that's where you're going to get the data to answer that question. And that's all I have time for this video.